Hopefully this is going out live, and we were just going to do a review of some of the containerization processes, specifically some of the security technology that's been coming out lately. Looking at two technologies specifically today. We'll see how far we get, but we're going to look at the Google gVisor security component, and we're also going to look at the KataContainers solution that the OpenStack community, along with Intel, has created and released. We can always start with our GitHub link as the principal way of looking at some of this technology. So really, gVisor is sort of a shim. Unlike a hypervisor-based environment where you might have a virtual machine and a Linux kernel and the full operating system, the idea behind gVisor is that it sits between your running operating system and the running container specifically, and it replaces the runC runtime engine with the runSC engine. So we're going to look at sort of implementing that, and so the point here is that you have these different layers of interaction, right? And the machine interaction is at the virtual hardware level. So this is the virtual machine manager. This is part of how the kernel works and how you get a hypervisor within the kernel. And then you have another operating system. This is an independent kernel. So this is the classic machine level virtualization that we think of when we talk about virtual machines. On the other hand, there's this concept of rules, so where your application and the host kernel have some level of isolation, just because you're limiting what the application can get from the kernel. And in a sense, that's part of the direction that gVisor was looking at, but basically they put a shim, this gVisor kernel, between the resources. So this is different than the virtual machine model, which is defined here, where I actually have a virtual machine hardware layer, and I sit instead between the host kernel and the application. So it looks a lot like what the isolation that you get from something like AppArmor or here SELinux, SEComp, SecComp based security, but we're doing it at a software layer above the host kernel. Now that's the gVisor model. The KataContainers model, on the other hand, you'll find their pages. I should have jumped on the GitHub page instead. Really what we can do here, let's see. Oops. We'll start with their pages. So the idea with KataContainers is that effectively we use the virtual machine management layer and a kernel that's specific to that container environment, using this concept of Intel clear containers and the virtual run engine for containers that came from the Hyper group. Where was their quick start? Yeah. Okay. So basically, we can run through this process as well. I think the gVisor model is a little easier to implement, though, and that's one of the other differences here. The gVisor environment has sort of been around for a while, and we actually have a pre-built executable that we can leverage. So that's really what we're going to do. We've got a Docker environment. I'm going to set up a machine. Let's see. Yes, and intent for this machine, of course, is to actually run Jenkins. But right now, we're running Docker, but we're just using the normal run C engine. And so what we want to do is change that over to use the run SC engine instead. Turns out that's pretty simple, because as long as I add this new runtime capability into the environment, let's see, Docker. So here we're editing the etc docker daemon.json file. There's nothing in it currently, but this is where you can add configuration to your underlying Docker system. So we're adding a new runtime directive. This doesn't make this the default. This just says that now I can actually call out the run sc runtime to run containers. And so if I actually do this, if I say docker run, for example, hello world. So we'll go ahead and grab the image, and it runs it. This is the normal way of running it. But I can also, basically following little instructions here, we can also say docker run, add the runtime parameter. System control, restart our Docker daemon. Okay, now, hopefully now we'll run this. Well, yeah, we actually probably need to have the run sc runtime. That's a good point. So I'm going to go ahead and actually we can just leverage their little script here, or scriptlet. So this is going to go ahead and grab the run sc. It's going to grab the checksum. It runs the checksum process. That's here SHA 512. So it's comparing the checksum that we downloaded to the file that we downloaded. Made sure that it's runnable, and then the last step is to move it into user local bin. This way our run sc service runs. And now, if we tell Docker, we shouldn't have to actually restart Docker, because it knows about the potential runtime that this should now run. So what that really means is that we're now using the run sc runtime in this particular execution versus the run c runtime. Of course, the point is, hey, if I now do this, I can actually go ahead and launch our configuration this way. So I'm downloading the Ubuntu image, and now I'm in Ubuntu Bash. If we look, we can see that now we're actually using the run sc runtime to launch some of our Docker services. And that's really the point. I still have the ability to go ahead and not do that. So this is now secured in that all the syscalls that this container is making back to the kernel are passing through the run sc runtime, which also does basically this static checking of resources to make sure that our connections back into the kernel are still functional and viable. If we launch without the runtime directive, right? So we can do the same thing here. Go ahead and we run that exact same Ubuntu image. You'll see we don't download it again. We just go right into it. Now, if I do a search, run, what we see now is that we're using the run C runtime, right? So of our run instead of run sc, and that's so here was our previous run. right, where we were actually using a run SC as our resource, and now we're using the runtime run C. So you can see that the utilization of this particular security resource is pretty good. There are some issues. I think they're actually spelled out here in this GitHub repository as well. And one of the biggest is that while this shim is trying to capture all of the different systems calls that one might make, it's not complete. I think last time I was here, they even had some systems, so they've tested a lot. Probably most of what's being used heavily on the internet today, but there are things that have been called out. Well, it looks like they fixed the Postgres issue. Yeah, so last time I was here a couple of weeks back, Postgres actually had a bug. Looks like here there are a couple of more that they've found have some potential issues. The Nginx one actually is actually an important one because that's a fairly commonly used proxy. And the whole point is you want to basically be able to just change over to this runtime, use this as your runtime for everything. And you know, the team here is a team from Google. They seem to be really responsive. Like I said, a couple weeks, and I know that they have fixed at least the Postgres bug that they had run into. Looks like there are a couple others that maybe are a little harder to implement that haven't gotten covered yet. But overall, this is a pretty straightforward way of improving the security. Now, is this as secure as what the Kata community is trying to do? No, it's still a software layer. There's still going to be bugs in this particular layer, and honestly, even in the Kata space, there are probably still going to be bugs as well. But the concept is still the same. Now, you know, to provide that shim version of security between the resources, and you can see that from the perspective of launching this, this is really pretty straightforward. There are even processes for building it yourself. If you really have concerns about security, you really should be building from source, so you can actually get the source. That's always a good idea to go through, do your own validations. I don't know if this is yet being checked by the standard community of security checkers, although I know that the community that's building this tool is very interested, obviously, in system level security. So pretty powerful tool from that perspective. Now, as for Kata, I haven't actually tried to build Kata before, so it's one of the reasons I was sort of stumbling around a little bit looking for these resources. I was going to go see if looks like potentially there is no default binary that we can grab, so we're actually going to have to go build this with Go, and I don't believe I installed Go yet on this machine. So what we can do, first off, I can exit out of that. So that I can do that. That may not be right. No, that looks good. So you can see what version of Go we get out of this. It seems like we do have a version requirement here of at least 1.8. I'm assuming that Ubuntu, even though it's LTS, 1.6. So we need a newer version of Go. So that's not going to help us. There we go. Let's get the latest of Go. So once we have this, Oh, I should have done a snap. Anyway, great. So we'll have our Go version. Let's also make sure we probably don't have GCC installed. So we'll go ahead and do that next, just as soon as the Golang PPA installs. And we'll give this a go. Looks like we have some of the basics. After we do that, what else do we have to do here? So we do have to have the kernel, and that's really sort of one difference. You can already see that there's more complexity with the Kata solution, but remember, the whole point behind Kata is that we're actually not just running effectively this lightweight shim kernel between the Linux kernel and our system. We're actually running this on top of the hardware virtualization layer, and so we actually do have a little bit more work to do to get there. So we'll get these resources put together and see if we can't launch this environment. It's still downloading. Bane of doing anything fast, downloading. And this is even a cloud machine, so I've got all the bandwidth in the world. But we'll grab these resources and we'll get this going. I always say that this is like watching paint dry. Anyway, while that's downloading, we can continue to investigate here. So looks like we've got some tools that we'll get, configuration that we have to look at. So we have a choice of a initRD or rootfs. It's kind of funny because initRD is effectively a root file system. Okay, so we'll go and look at the configuration just as soon as we have this installed. And I think we'll pick one versus the other. And I'm assuming that these initRDs actually are part of what gets downloaded as the packaging. Oh no, actually I guess we'll have to look at these sections. Actually, we'll just go ahead and pop this open. So if we go with the initRD model, okay, so we can pull the resource down. Not sure where we're getting distro from. Looks like the default path is rootfs model, so I think that's the one we're going to go with. And then we can all this. Now, why do they always put the $sign in? Because it makes it impossible to copy and paste. All right, so we should have a Go version. No. Then I just go install a PPT. Let me try one more time. You'd think this would be easy. Oh, of course. All right, well, with that, all right, that's much better. Now we also need to make sure we had GCC. And make. I think that's the other thing that was required. All right. So we have our requirements. So we don't need to go any further here. So we were going to run through these steps here. So we're going to go grab the KataContainers runtime. Okay. And so hopefully this runs smoothly. All right, looks like that. That's configuration. generated file, and then the question was if we're going to use a initRD or the runtime image, or the rootfs image. We can go ahead and run this and just see if our binary works at least. Okay. Let's try and understand what's available to us. Now, this is running on a packet.net machine, type 1 small instance. So they're a little Atom-based environment. And it looks like it's at least capturing things. It does not like... No, so nested virtualization is not turned on. So this is a warning, so I think we're going to assume that that's still okay. We should be able to turn nested VMs or nested virtualization on because, again, this is hardware, and I know that the hardware supports it. It does see KVM, so we are available to at least run against the proper hypervisor solution. So no, it looked like further down the configuration would prefer to use the rootfs model rather than initRD. Make sure you have initRD in comma configuration.toml file and comment to image line. So let's find the image line. I'm just going to do this manually. I'd rather look at the file. I should start to look at that. So let's find image. I see. So basically they're saying this is the rootfs version and this is the initRD version. And I'm assuming that if we go down here a little bit, it says if you want to use rootfs, then comment out the initRD line. Yep. Maybe pick one. All right, so we're going to assume rootfs for now, and we'll see how that goes. Already I can tell you one thing. If I were just wanting to play around with some secured image models, I think the gVisor model has a lot of value just because of the simplicity, but it's not going to have nearly the performance of this solution once we get this going. So most of this really should be done automatically anyway. There should be an initialization script that just takes care of this for you, or better yet, we get this implemented within the operating system. But at least for now, this is an approach. So one or both. Well, here's the real reasoning. So initRD images are small and rootfs images are large. I go for small over large. So we're going to switch gears here and say, let's go ahead and go with an image instead of initRD. rootfs. So we're going to go with the init model. I don't need full debug. I just want to see if this actually works. Looks like we need to grab a proxy. Go ahead and do that. Looks like we need to also build the proxy. Let's see what's going on here. Excuse me. That's much better. Now I can also go build the shim. Also, at least the instructions are working. Again, I need to maybe add a little pull request to get rid of the $ in front of everything. So we do not need to build our own agent, assuming one exists. But you know what? Since we're here, might as well just do it all. You know, if you're going to do it, go for the gold. That's my impression. All right, and then I guess we'll get this as well. So we're going to need this to build our initRD images, possibly. Well, that didn't work. All right. So we're going to create an initRD image. So we're going to skip that and custom image. No, I'm not going to do that. Create initRD. Okay, so it looks like I have to create a root RD image anyway. Okay. So we have to basically come back here. Okay, so we do have an honest builder directory, but there's just no rootfs. So this isn't going to do anything because this doesn't exist. At least that exists. Okay, so we're making some progress here. So I'm going to go ahead and do this. Okay, so we have a bunch of different distros. I think we're going to do Alpine just because it's the lightest weight one of the bunch, at least as far as I know. So I guess it looks like I need to export. Export this. All right. Looks reasonable. Running along here. All right. Everything there looked good. All right. All right. So we've gone that way. You know, if you read ahead, you're going to get there. We're not adding a custom agent because we didn't build one. And then looks like we might just as well do this. We'll run the script as well. Exercise for the user would be to script all this so that you don't have to copy and paste these ridiculous things like this. I'm sure that that's been well defined somewhere else. That's interesting. Why is it pulling? Maybe the image builder tool runs within a Fedora Docker container. Yeah, interesting. So we're definitely building from within a Fedora environment. And, I wonder if that error is important. So it did actually complain here. We'll just go on as if everything's fine and see how this comes out. So we wanted to actually try to create an initRD image. That was the whole point here. So that should still be there. It's almost like it's redoing the same steps we did up here. RGFS shell, Docker image. Let me see. Agent init. Do we have that there? We did not. Okay, so the difference is this agent init parameter. So we'll go ahead and we'll follow their instructions. I'm going to do these exports again. And we'll get rid of that directory. I guess that's clearing out the previous work. We're going to pop back into the root builder directory. We'll go ahead and run the build path again, but this time with this new agent init parameter. Okay, agents installed, that's fine. Oh, okay. I thought I'd seen an error fly by. That's what I was trying to find. That looks good. Okay, so it looks like that step ran properly. So yeah, we've done that. Add your custom agent. We didn't need that. Because now we still need to do the actual build. There, okay. I'm just copying and pasting these commands. Hopefully this will give us a system creating an NRD. That looks good. So far, so good. All right. Interesting. Guess we better be in that directory. So image. All right. Show KataContainers image. Let's see. Okay. Okay, so it's going to link the long name to the short name. Fine. Great. All right, and then install guest kernel images. I guess we need to do this, but you know what? I'm not going to do this copying one line at a time. We're just going to grab this here chunk and make it a script. Guest. The first thing to do is get rid of all these dollar spaces. So substitute for beginning a $, a space, nothing. You have to escape the $sign there, though, otherwise it'll think it's just looking for lines that have nothing in them. So, all right, we're going to run this bash guest.shell. It's promising. I should have set -X so we could actually see what it was doing, but it looks like I'm grabbing some kernel information, grabbing the actual kernel, some patches that look like they need to be done. Kernel art gets set in here somewhere, I hope. let's see where kernel architecture gets set. So not quite sure how that's going to work. Okay, so looks like that blew up. Let's try that. And then retry our script. Right, well, that's definitely doing better than the previous one. Also good to update Docker. Okay, actually, I don't think we need to change that. It's just trying to make sure that our default runtime is run C, which it is. And then we can actually use the same method we used with the run SC to set the Kata runtime like this. So we'll do that. We'll do that using the other tool. So we get this. Okay, so image is ready. All right. Well, that time it worked. So I just needed that one additional binary tool. Now we're going to go ahead and add this into Docker JSON. Go ahead and create another. Set our path. Okay, close that. Start Docker. Okay, so hey, let's give it a go. What do you think? We might have to run Alpine because I'm not sure. Can you light? Not sure where that's supposed to come from. Let's see if we can find it quick this way. All right, looks like maybe we're still missing a piece. Okay, talk to me here. Let's see if okay. So let's install QEMU and see what happens. I guess that means I also need to change the default in the configuration.toml file. Okay. Looks like I want okay, well, still not quite there. Yeah. Yeah. All right. Well, we tried, and well, let's try BusyBox just in case there's something. Let's have one quick look here. Yes, others have been trying. Let's see if this is the missing component to get the rest of our virtualization layer installed. No, still not. Okay. Well, I'm out of time for today anyway, but looks like we made some progress here. The gVisor model, obviously fairly straightforward, but again, it's a lightweight shim that sits between the current running kernel and the container that we're launching, whereas the KataContainers project is really sort of creating an integration into the actual hardware hypervisor model and implementing that. So we'll see. We'll see if there's something else that we can do. Maybe next time we'll continue on with this and see if we can't get caught up and running. I know that the technology is interesting, but doesn't look like I have a quick response to this. Newer version of QEMU, maybe. Okay. Well, anyway, actually, it looks like that is the issue. So, how do I get a newer version of QEMU? Let's just try this real quick. Maybe I should try an 1804 image instead of a 1604 image. Let me see, does it just say, yeah. Okay, well, that's not going to help. Here, let me see if there's a All right, so we'll have to figure out a way to get a newer QEMU if that's necessary, or we'll launch with 1804, and maybe we'll have a look at this next time. So we'll get back to it. Thanks for watching. Hopefully this was useful, just an idea of sort of how these pieces fit together. Obviously, running through some of this, just following the instructions is one approach. Scripting, it certainly helps, and automation is one of those areas that we sort of do focus on. If you enjoy this kind of configuration, this kind of setup, do let us know. Comments are always welcome. Obviously, this will also be posted on YouTube, so you might be finding us there. And we look forward to having you join us next time we run a session like this.